this short addendum to the formal derivative video, we're going to talk about the formal antiderivative. So just as we can calculate the formal derivative by differentiating each term and hoping for the best, we can do the formal antiderivative by anti-differentiating each term and hoping for the best. So if we have a function f of z given as a power series a n z minus a to the n, then we can form the formal antiderivative of each term. The theorem here is that the formal antiderivative is truly an antiderivative, and not only that, it has the same radius of convergence. The proof for formal derivative was super hard, and you expect integrals to be harder than derivatives, so you expect this to be really hard, but it's not. It follows as an immediate consequence of the statement about formal derivatives. So the secret here is that if you calculate the formal antiderivative this way, then f of z is, so this is the proof, f of z is the formal derivative of cap f of z. So in other words, if you were to calculate the formal derivative of this, then the n plus 1s would cancel and you would get this, right? Because you calculated the formal antiderivative that way. So the formal derivative would yield f of z. And if that's true, then that means that f of z is actually equal to the true derivative of that with the same radius of convergence by what we just proved before. So they must have the same radius of convergence because one is the formal derivative of the other, and it must be the true derivative because we proved that the formal derivative is the true derivative. And so what that means is that cap f is a true antiderivative of the original function. So that's an antiderivative of the function f, because its derivative is f. And that's all we need to do in order to reassure that formal antidifferentiation of power series yields an actual antiderivative as we would hope. So things that can be done term by term include addition, subtraction, constant multiplication, multiplication if you know what you're doing, differentiation and anti-differentiation. All of these operations apply correctly when reasoning term by term about these power series.